Okay, this is 9.5 homework help. The first problem gives us this system of inequalities right here, and it wants us to know where the solution is. The solution is either A, B, C, or D in one of those regions. So what I do for this is I like to look at both of these lines. So I'm going to look at this line first. Now figure out which line this is. So if I look at plugging in 0 for x, for example, I get 0 for y. So that point is right here. That's got to be the blue line then. So there's the blue line, and the black line obviously then is this line right here. All right, so when I think about shading this, I pick a test point. So for the blue line, let me pick an easy point. Let me pick the point 1, 0. If I plug in 1, 0, I get 3 is less than or equal to 0, which is not in the solution set. So when I plug in 1, 0, 3 is not less than or equal to 0. Therefore, I would have to shade this part of it, this side of the line. And then the black line, then I do the same thing. I say, okay, choose a test point. So an easy one. I'm going to pick 0, 0 and see if that's in the solution set for the black line. Now, when you pick 0, 0, you get 0 is greater than or equal to 6, which is not true. Therefore, I'm going to have to shade the other side of the black line, which is this side up here. So the overlap would be this part, which is D. Okay, the next problem wants us to graph the system of inequalities and tell whether it's bounded or unbounded, and then list the corner points. So you're going to have to graph all of these, which is going to be tricky, but draw a graph here. Now I'm looking at mainly the first quadrant of this graph because it says that these two constraints say x has to be greater than 0 and y has to be greater than 0. So let me draw this down here. So I'm going to graph these lines. Now to graph lines in standard form, you might remember it's easiest to plug in 0 for x and solve for y, in which case you get 4. So 0, 4 is like right here. And then, do the same thing, plug in 0 for y, in which case you divide both sides by 2 and you get 6. So here's that point. This is 6. There's that blue line. Now figure out which way to shade. So if you plug in 0, 0 as a solution point, you get 0 is less than or equal to 12, which is true. So I'm going to shade this side of the blue line. Okay, the next line then, do the same thing. Plug in 0 for x. I'm graphing this line now. And you get 6 for y. And then plug in 0 for y, and you get 4 for x. So that's this line here. Figure out which way to shade. Plug in 0, 0, and you find that 0 is less than or equal to 12 is a solution set. Therefore, I'm going to shade below the black line. If I shade both of those parts, I get this is my solution set. Now that is bounded. That's a quadrilateral. It is bounded. And they want the corner points. So the corner points are obviously this point here, which is 0, 0. This point here, which is 0, 4. The next point is the intersection of these two lines, which I actually have to find by solving this system. This system right here. I'm sorry, I have one more line to graph, and that's this one. So I'm going to graph that one real quick. That one is, if you plug in 0 for x, you get 2 for y. Plug in 0 for y, you get 2 for x. So 0, 2 is right here, and 2 zeros right here. There's that line, and we need to figure out which way to graph that line. So pick the point 0, 0. 0 is not greater than or equal to 2, so I'm going to graph above that line. So my last line goes like this. I need to graph above it. So that means my solution set is actually just this region. So I need to redo these points then. 0, 0 is not one of them. One of them would be like 0, 2, which is right here. So 0, 2, this point. Next point would be, try to do a different color here. 0, 4. Now the next point is this intersection point right there between these two lines. So that's solving this system right there. In order to do that, I'm going to multiply the top equation by -3. That gives me negative 6x plus negative 9y is equal to negative 36. And I'm going to multiply the bottom equation by 2. 2x plus 4y equals 24. Now when I add those together, I get negative 6y equals negative 12. So y equals 2. And then to find x, you plug it back into any one of these equations. I'll plug it back into the first one. That'd be 2x plus 6 equals 12. Subtract 6 from both sides. 2x equals 6, so x equals 3. So there's the point 3, 2. And then the next point is the point 4, 0. and the last point is the 0.20. Okay, same thing for the next problem. I'm going to pause it and graph this region. It's a tough one to graph, and I'll show you how I did it. Okay, so here's all the lines graphed. You can see these are going to be all my corner points that I'm going to need to find. The only tough one to find really is this one here, because it's the intersection of these two lines right here. So I'm going to do that first. I'm going to multiply, actually just add the equations together for me, and you get 8x plus 0y is equal to 32 and 24, make 8, so x is 1. So this is 1 comma, I'll plug 1 back into either one of these equations, and you get negative 32 over 7. So there's that corner point. This is obviously the point negative 6 comma 0. This is obviously the point negative 6, 4. This is obviously the point 8, 4. This is the point 8, 0. And I want you to list these vertices. And I want you to start clockwise, starting with the lowest y coordinate, which would be this one here. So 1, negative 32 over 7 goes here, and then you got to work your way around. So negative 6, 0. You get the idea. And the only two lines that are tricky to graph are obviously these last two lines here. And you want to do what I do, which is plug in 0 for x when it's in standard form, find the corresponding y value. That gives you the y-intercept. Plug in 0 for y and find the x-intercept. So, and graph those 2 points, which is what I did. Okay, this next problem wants us to choose 3 inequalities that form the system. So the first one's pretty easy. This line here, we want to graph, that's obviously y equals negative 4. But we want to graph all the points that are greater than that, so we want all the points greater than or equal to. So we're looking for that, and that's G. The next two ones are a little more tricky. I need to graph this line here. I'm going to do slope and y-intercept. So let's see. The slope is up 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. So it goes up 8 over 4 for the slope, which is 2. So that'd be y equals mx plus b. So that'd be 2x plus b. Now I don't know what the y-intercept is, but I do know this point right here, which is the point negative 3, 0. So I'm going to use negative 3, 0 and plug it in order to find b. So it'd be 0, and this would be negative 6. So addable to both sides, you get b equals 6. So my equation becomes then, if I plug b back in here, is this equation. But they have them in standard form. So first of all, let me figure out what the inequality is. This is the line that right there. It's the equation for it. But I need to figure out which side to shade. So 0, 0 should be in the solution set. So when I plug in 0, this should work. So you get, this will be 0. So it should be greater than or equal to. So I'm going to insert that symbol right there. And I also want to put it in the standard form that they have. So I'm going to subtract 2x from both sides. And I'm not seeing this one, so let's try to multiply it by 2, and maybe we'll see it then. No. Let's multiply it by 4. So actually negative 4. If I multiply it through by negative 4, I get 8x minus 4y is greater than or equal to, the sense of the inequality will switch if I multiply by a negative 24. So I know that's really tough. But that equation should be up here somewhere. Yeah, it's the first one. Okay, and I'll have to do that same thing for the second line then. So that's this line here. Now the slope is the opposite, so we had a slope of 2. We're going to have a slope of negative 2 now, it looks like. But let me double check that. Goes down 8 and over 1, 2, 3, 4, 5. Nope, I lied. Down 8 over 5 would be negative 8 over 5 for the slope. So it's y equals mx plus b. I'm going to use, let's see. I'll use this point down here as a point. So that goes over 1, 2, 3, 4, down 4. So 4, negative 4. I'm going to plug that in for x and that for y to solve for b. So negative 4 equals negative 8 times 4 over 5 plus b. And that gives me this, and I can add to both sides, which gives me a b of, let me get a common denominator, so it'd be 12/5. So let me plug that in up here. Now I have this equation. Now I want to figure out what the inequality is, so I want all the y values that are less than or equal to. Let me double check that. If I plug in 0, 0, I should solve it. So when you plug in 0, you get less than or equal to 12/5, which is true. So there's my inequality. And I'm going to put it in standard form by multiplying through by 5. So that gives me 5y is less than or equal to negative 8x plus 12. And then I'm going to add 8x to both sides. So 8x plus 5y is less than or equal to 12. And I'm going to look for that one. And that's B. So it should be A, B, and G for me. Okay, so the last problem is problem 5, and it wants you to graph this region right here and then tell what it is. So right away you can tell that x has to be bigger than 0 and y has to be bigger than 0, so you're talking about going this way and up. So you're talking about the first quadrant. So I'm only graphing the first quadrant. Now I need to graph these two lines. Once again, in standard form, if you plug in 0 for x, you get 7 for y for the first equation. So that would be up here where this is 7. And then if you plug in 0 for y, you get 7 for x, so that'd be over here. So I'm going to graph that line blue or black. That's this line here. Now I need to figure out which way to shade. So if you try the test point 0, 0 and you plug it in, it does solve the inequality, so I'm shading below it. Okay, I'm going to do the same thing for the next line. I'll do this in blue right here. Plug in 0 for x, and you then get 8 for y. And then plug in 0 for y, and you get 8 over 9 for x. So I'm going to plug those points. 0, 8 is right here. 0, 8 is up here. And then 8/9 is a little less than 1. So that'd be way over here. And that line looks like this. And you need to figure out which way to shade it. So if you plug in 0, 0 for your test point again, that does solve the inequality, so you need to shade this way of the line. So I can tell from looking at this then that my solution set is what I'll shade here in yellow, which is this region right here. That's the region that I need to highlight. Now it wants, that's a quadrilateral, so I can say that's a quadrilateral, write it out. And then it wants the vertices listed starting with the one that has the smallest x value and the smallest y value. So that'd be starting with 0, 0. And the second one would be up here, this vertice right there, which is 0, 7. The next vertice is right here. I'll highlight in green right here. And I need to find that by solving this system right there. So I have x plus y equals 7, and I have 9x plus y equals 8. And I'm solving that. So I'm going to multiply through by a -1 to the first equation and add them. And that gives me 8x equals 1. So x is 1/8 for that point. And then plug it back in to find the y value. So I'll plug it back into this original equation to find the y value. I have 1/8 plus y equals 7. So subtract 1/8 from both sides. And that gives you 6 7/8. So that point, you can list that. It would probably take it as a mixed fraction, actually, 1/8 and 6 7/8. But you might need to do that as a decimal. And the fourth vertex is down here, which that was 8/9, 0. So there's the vertices of that feasible region.